Hello, everyone, and welcome to the Big Mountain Dev and Data After Lunch session with Casey Mao. You're in room 2, and after this short introduction, Casey's going to present how I became a data engineer and why you should too. Casey and I will be watching for questions both in Slido just to the right on your browser and in BMDD room 2 on Slack. If you're having issues with the conference today, there's also a BMDD support Slack channel where you can get some quick help from our volunteers. Now, one of the trivia tidbits that Casey gave me while we were getting set up is that his family requires everyone to learn to use a unicycle before they can get their driver's license, something I've been fascinated with but never learned myself. And with that introduction, I'll go ahead and mute now and turn the time over to Casey. Thank you, Casey, for being with us today.
Thanks, Chad. Let me share my screen so you don't have to just look at my face. So just like to say thanks to all the sponsors today. You can see them over here. And thanks to Utah Geek Events, Pat especially. He's been just so helpful throughout all of this as we've been getting ready. Thanks to all the people putting on this event. It's great. Also, make sure you send your love to all the speakers. They worked hard to put their presentations together. So, and thanks everyone for showing up. Today I'm going to talk about data engineering. What is it? Why is it? And how do I become it? So who am I? I'm Casey Mao. I'm a data engineer at Pluralsight. You can see here some of my handles and accounts you can follow. So if you want to get a hold of me, there's my personal email. Feel free to reach out. And please do ask questions. As soon as you have a question as I'm going through something, just send it to Slido or Slack. We're monitoring, and I can kind of weave that in as we go. So thanks for that. Thanks for your participation. I want to kind of go over what we're going to talk about and what I hope that you guys leave here knowing or feeling. So data engineering encompasses a lot of different skill sets. It's kind of a big umbrella. And you don't need to know all of them to get into the field or be a good data engineer. Another thing that I want you to know is there's many paths. I want you to leave here knowing that there are many paths that lead to data engineering. So hopefully you get a little bit of sampling of some of those paths. We obviously won't cover all of them. There's many. But maybe you can see a path for you on how you might get there. And also, you can't really talk about data engineering without talking about data in general and how important it is to companies and to your personal lives. Understanding data, your personal data, and how it can help you is just so important. And because it's so important, the demand for data engineering is just going to go up and up. So it has a bright future if you choose to go on that path. So I'll just start out with my story on my path to get here. I'll go all the way back to the beginning. Not quite to the beginning. I'll just start in high school. You can see on the left here a TI-83 Plus calculator. My favorite, fond memories of that in high school. And I created a little text-based RPG. It's not near as beautiful as is depicted here, the game I made. But you could put in strength and energy and health, and you could fight monsters and level up and, gain new skills and continue to fight monsters and progress. And it was, the storyline was a little bit lacking, but I just wanted to level up anyway. So I shared that with tons of friends, got into, wanted to create another RPG and Link style game. I had a lot of fun with that. Sadly, I didn't really like the school classes on programming. They kind of felt a little dry. And as I got to later in high school, I got to the point where I wanted to choose what I wanted to be. when I grow up. And a lot of people were like, hey, you're great with computer science. You built these programs. You should go into computer science. And I, my smart self back then, I said, well, Steve Jobs and Bill Gates, they've already squeezed out all the innovation that's going to happen in this field. It's already saturated. So I better go into something else because there's just going to be too much competition. And so I decided to go into mechanical engineering. I thought robots, that's going to be the thing. So you can see that depicted here by little Wally. I went to the U of U and I started going down that path. About halfway through, the classes started getting really hard. And I was taking statics and strengths. I was taking material, electrical engineering, and thermodynamics classes, and they were just hard. And it's not just because they were hard that I was kind of feeling resistance there. One day, you need to know some computer science in mechanical engineering, and I took a MATLAB class, and in that MATLAB class, we started doing things like the Monte Hall problem. We created a Sudoku solver. And in contrast to those hard classes I was taking, that it was kind of drudgery to me, I was just loving this computer science class. And I would complete assignments and go above and beyond them and start to tweak things to figure out what would happen next. I'd stay after class and talk to the teacher and ask him more questions, and I was eating it up. At about that time, to much to the chagrin of my wife at the time, I decided to change majors. I was going to go into computer science, and I did. I changed majors, and it was so much fun going into computer science. And about halfway through that, again, I got hired on at a small startup called TaxBot. There was only 15 of us at the time, and they hired me on as a software engineer. They had a nice big backend in Django in Python that I was help maintaining, and I wore every engineering hat under the sun. While I was there, I was interfacing with external software development teams. I was kind of wearing a organization hat and vision for the future, CTO type thing. I was doing kind of in the weeds and feature development for the back end, learning about SQL and database structure and infrastructure. And it was scrappy and it was fun. But I was kind of looking as I was progressing there, and I was kind of looking for more mentorship. And I wanted to be in a little bit bigger of a company that had processes around how they do development. And I started going to meetups and here in Utah. And one of the big companies that was sponsoring a lot of these events or speaking at some of these events was Pluralsight. And as I learned about their philosophy and kind of saw their maturity and mission, I ultimately decided I wanted to apply there. And so I saw a data engineering position open up. And even though it was a bit of a stretch to call my, junior developer self a data engineer, I thought I would apply. And I didn't know this, but at the time, the data engineering team had a database administrator, a SQL analyst, and a product manager. And they were looking for a data engineer, but for someone that had Python experience that also had some experience in software development, so that they could maybe bring some coding best practices. And they hired me, and it's been a few years since then, and I've learned a lot along the way. But that's kind of how I got to be a data engineer at Pluralsight. But what is data engineering? I promise it's not aliens. And if we talk about data engineering, one thing you have to talk about is kind of the data landscape and where they fit. And you can't talk about the data landscape without talking about the data hierarchy of needs. I know it's a little cliche to talk about these, but I think it paints a good picture for kind of some of the struggles that people face. So when you look at a hierarchy of needs, you need the needs at the bottom of the pyramid need to be met before you can start moving up the pyramid and satisfying needs higher up. So on the left pyramid here, we see, you know, data collection, raw data, structured data storage as you move up, descriptive analytics, diagnostic analytics, predictive modeling, and then prescriptive optimization. So each one of those builds on the work done below it. One thing I like about the other pyramid on this page is it kind of maps, it shows a mapping of where like roles might fit on here. So at the bottom, you have instrumentation, logging, external data, and you move up into ETL, data flows, unstructured data storage. And then you move up a little higher into cleaning and prep. And you keep moving up into analytics, training data, features, into A/B testing, experimentation. And finally, after you've satisfied all of these things, maybe you could do AI and deep learning. So you can see the mapping here at the top. You have machine learning, data science, and data analysts. And at the bottom, you have data engineer and data infrastructure engineer. And so really a data scientist or data analyst, they can't do their A/B testing or analytics or metrics without clean and prep data or reliable data flows or instrumentation and logging. And so each of them build on each other. More and more today, we're actually moving towards kind of cross-functional teams in the data space. And so instead of a giant pyramid where people are siloed in their respective layer, you might have like a slice of this pyramid where you have machine learning engineers, data scientists, data analysts, data engineer, and data infrastructure engineers working more closely together on specific projects or a specific problem that crosses all the way up and down this stack. So that's just a little bit into those things. But if we move on, you also, you know, the equally cliche, you have to talk about Venn diagrams. The Venn diagrams of data science here on the top and left and right, and then some more that include some data engineering positions and things. So for a data scientist, they need math and computer science and subject matter expertise. And you can kind of see where you fit based on the skills and things you have. I think it's interesting that on some of these Venn diagrams, you actually, in the middle, instead of data scientists, you actually have unicorn. And we all know that unicorns don't exist. But for data engineers, and we kind of see this in this Venn diagram over here, this is kind of a path I took. I was in software engineering. I had software development, web services, jQuery, HTML. I had some of these skills, you know, I had Linux skills and SQL. And as I moved into the data engineering space, I learned a lot about Hadoop, about ETL, about Hive and databases and Python and data analysts and data analysis. And a lot of these overlap with data science. So you can kind of see how it's a blended sphere. This is doing this is trying to paint some lines around what a data engineer is versus other things, or a data scientist is. But really, it's kind of there's a lot of gray area in that. So what are some paths that lead to data engineering? I told you my story, which is kind of the software engineering route. And really, as a software engineer, you work with data every day, but maybe not at the scale that a data engineer might. And I think it's a natural progression for a software engineer to be interested about data, because they do use data every day. But each of these paths, at least these three on this page, I put these here because there are actually one or more people on my team currently that fit in these boxes. And so I kind of wanted to go through them. There's the there's the reformed data scientist. And this person was at a different company as a data scientist, and they were trying to answer a question or solve some problem or find some analyses that they were doing, and they didn't have all the tools they needed. They went to ask operations for some infrastructure that they needed to run some models on, or the data that they were trying to use was messy and dirty, and they needed to clean it up, and they didn't have the tools they needed. And so they decided that if they couldn't get those things and they had to do all that for themselves, that they were going to learn those skill sets. They were going to learn about infrastructure. They were going to learn about data cleaning and data processing. And so they decided to move down the stack and start looking for data engineering roles so that they could gain the expertise in those roles so that they could be effective data scientists. I know a lot of people at some of the data engineering meetups here in Utah come from that background, and they realize that to be effective data scientists, you need those skill sets somewhere. And a lot of them look inwards and say, I need to build those skill sets. So that's where one kind of path is. There's the DevOps of data, and this person or people are usually just operations heavy people that have an interest in data. And usually the operations people have like interest in a lot of different technologies. And the person I'm thinking of in particular was trying to decide between Kubernetes and data science stuff. And they, for no particular reason, decided to choose to go into data. And as you can see on the data hierarchy of needs, to make data happen at a company, you need infrastructure, you need operations expertise, and so that's a big part of the job. And then there's the SQL transformer. It's a database administrator or analyst who's really good at SQL. They know about partitions. They know about how to make this query engine performant and what are the pros of this engine versus SQL Server, and they could tell you what the underlying processes are happening at the engine layer, and they just got so good at SQL that they decided we need to automate more things. We need to get better at more things, and they move into a data engineering role. And it's a great fit because a lot of transformations happen in SQL, and so it's a huge piece of what you do as a data engineer is just work in SQL. So those are just some of the paths. I wanted to touch on those and mine, but there are many paths that can lead to data engineering. So I kind of wanted to talk about Pluralsight and at least the data engineers' vision at Pluralsight. And so this is it right here. We are a force multiplier for data practitioners, co-creating a data-driven Pluralsight in pursuit of our mission to democratize tech skills. So Pluralsight's mission is obviously to democratize tech skills. If you need tech skills, go to Pluralsight. We're great. I'm not biased at all. But the piece I want to focus on is being a force multiplier, because that's where I see that us as data engineers at Pluralsight fit. So how can we be a force multiplier for a data practitioner at Pluralsight? And one way is we can create tools. We can make SQL tools that make running SQL easy for them. We can make performance in their engine of choice faster so that they can get to the insights they need faster. We can create orchestration so that when they want to tie jobs together, it's easily configurable and can run. And we can train models and deploy models into production in an easy to use CI/CD pipeline so that they can push code and it can run through the build process and be deployed in a quick fashion. And so all of these things, all of these tools we build, the engines and the all these things we do, it isn't just to make us because we can. It's so that they can be faster at what they do, so they can answer the questions that they want to answer and make the predictions they want to make in production faster. And so hopefully, as they're quicker at their jobs and they're able to do things better, then that ultimately helps Pluralsight. So that's kind of what I see us as we're hopefully working closely with the data practitioners so that we understand them and we can help them the best way we can. So just want to give a few thoughts on data. I kind of alluded that data is important, and I mean we've all heard data is the new oil, and kind of what I wanted to touch on here is if you've ever felt the power, I guess, of data or being data driven. And have you been in the room when a new insight that was data driven like helped make a pivotal decision on your team or at your company? And I'll give just one example that recently happened. So there's some heartburn on our team around some processes that kind of centralized around tech debt. I'm sure no one has problem with how they handle tech debt and software. But we had some of these problems, and between us, the data engineers and our manager, we were trying to make the case to make some changes around our processes. And my manager looked at the data and aggregated some of the data and brought it to the discussion with some of the higher ups. And his arguments were so powerful, and they convinced all the higher ups. And it wasn't just okay, fine, you guys can do it this way. They were convinced enough to say, yes, we want to give you that. That sounds great. It's not just a begrudging, yes, that's okay, but they really turn to your side. And I felt that on countless occasions. And I know that as companies leverage data more, they're going to be more effective at accomplishing their missions. And that's why I think data is so important, but also kind of leading into data engineering. That's why it's important to get into data engineering, because it's only going to grow as more and more companies adopt data. So okay, I've convinced you, right? You all want to be data engineers, maybe. So where do you start? Here's a few questions like, who's hiring? What are they looking for? What skills do I need? What is better to learn, Python or Java? What about blah technology? Why aren't there more cat pics in this presentation? All these are really good questions. And this kind of leads into what I was hoping to cover next, which is a demo. I wanted to give a demo about data engineering, and I also wanted it to be kind of tied to what I'm talking in this talk. So first, I wanted to showcase a data engineering pipeline, but also wanted to use jobs, data engineer positions, to help leverage that. So what we're going to do is we're going to look at Indeed.com, and I'm going to switch tabs here to, I created a repo called Data Engineer Example. You can all go there if you want. It's Mausa/data engineer example. And it's just an example pipeline. It's not supposed to be necessarily a good pipeline. I make no promises. And we'll actually go over at the end of this some of the improvements or ways that maybe shortcomings of this. But I wanted it to be representative of maybe a few technologies or a few practices that a data pipeline might follow. So if we look at these steps here in this diagram, we're just starting at Indeed.com at a query. We're looking to be a data engineer, right? And if you put that into Indeed.com, what you get back is a list of data engineer positions. So what I did is I wrote a script that scrapes those URLs to these. It scrapes this page, and it goes through all the pages, and it pulls all the URLs for these and publishes them to a Kafka topic. So in this Kafka topic, there's partitions, and you can see that each record has an offset. And that's all this script does. It's single purpose, and it's kind of modular decoupled. So all it does is it publishes the URL for a job. One piece that I did do to make sure that we're only getting data positions was I search for data engineer, but I also filter out any titles that don't have data in it, which is usually, so we're not looking for like a senior software dev or something. We're just looking for data positions. And then after that, we have a listener here. He's consuming from this topic. And for each URL he receives, he actually goes to that URL using Selenium and a headless browser and Beautiful Soup. He extracts the text of the description. So when he extracts the description, he saves that to a flat file. That could be in S3, that could be in a blob store, that could be in Google Cloud Storage, or just the regular old file system. Today we're doing it in the file system, and we're saving it as text. If this were a real pipeline, we would probably be using Spark or Dask or Flink or some other type of ETL framework, and we would probably be saving these as Parquet files, which is a file format of choice that has a lot of nice properties. It's a columnar format, and we could go into that another time. But today we're just doing flat text files. So we're saving those on the file system, and then we're going to do some really fancy machine learning. So we're going to do some natural language processing. We're going to use the backward Euler to find the Jacobian matrix and look at the vector for the, I'm just kidding. We're not doing any machine learning. I'm not a data scientist. Really what we're just going to do is we're going to find the occurrence of words in this, in these files. So to tell you a little bit more about that, I want to talk to you a little bit about a feud that we've had. There's a data platform team and then a data engineering team at Pluralsight. And the data platform team uses primarily Java because they do a lot with Kafka, and they use Scala. And so they kind of a little bit look down on developers, or especially data engineers that use Python. But on the data engineering team, we're huge on Python. We use Python for a lot of things. And so what we're actually going to do in this step is we're going to look at the occurrence, how many times Python comes up in these files versus how much Java comes up in these files. So then we're going to write that to a Postgres database. And this could be any type of database. This is kind of representative of a warehouse. Most big data warehouses are like Redshift, Snowflake, BigQuery, and they just are a performant place that analysts can query their data. And this whole pipeline wouldn't be complete if we didn't have a BI tool that was surfacing all this in a pretty dashboard. Just like I'm not a machine learning engineer, I'm not a huge visualization guy. So at Pluralsight, we use Tableau for our visualization layer. But today, I'll just be using an open source tool called Redash. So I'm actually running this Kafka cluster locally. I'm using a Confluent Docker Compose image to spin up all the necessary pieces for this. I'm using another Docker Compose file to spin up a Postgres server, and I'm using Redash's Docker files to spin up their service here. So this is all running locally, and we're going to see it in just a minute. So here's the actual files. We can see there's a data directory for job descriptions. There's the external location. This is where I put the Kafka stuff. This is the Postgres Docker Compose image, and here's the Redash. So I cloned these things down and just ran them locally. If you wanted to, you could here in the env example, you could change from localhost on all of these things to something different, which, I mean, maybe someone could do. So everyone is welcome to go to this and try this out yourself. So what I'm going to do now is I'm just going to pull up some terminals here, and I'm going to do poetry run Python 02. So this is the Indeed jobs URL. So this is the part that's going to publish to the Kafka topic, right? I'm not going to hit enter yet. Then I'm going to do poetry run, and this one is the parse job HTML. So this is a consumer on a Kafka topic that is sitting and listening for new topics to roll in. So I'm actually going to run that. It's going to start consuming topics. There's no topics yet. And then on this one, we're going to do poetry run Python. And we're going to do the text data to Postgres. So this is the machine learning, right? Part of it. And what this is doing is it's looking for files. So it's going to wait for files. Every few seconds, it's going to check for new files on the local file system. So I'm going to run this one. And now this one's going. It's spinning up a little browser in the background. And it looks like it found 1,188 jobs. So that's good. That's how many jobs Indeed has in Utah on data engineering. So looks like we just got a question in. Thank you for your question. Did you use Scrappy for scraping the Indeed page? No, I didn't use Scrappy. I used just Selenium and Beautiful Soup. So as we can see, we're getting a lot of jobs. These are posting a lot of messages. And it actually is taking longer to load each page and pull out the description and save it. But that's okay because we have that Kafka queue in between it. So this can work at its own pace while this thing is just chugging along, spitting out things. And over here on the far right, you can see whether it's waiting for more files, but every time it gets a file, it inserts some values into the Postgres database. You can see the Python count, and you can see the Java count. So, so yeah, this will run for a little while, and this will run for a little while more. Oh no, it hit a problem. Looks like it couldn't parse that. Oh darn. We'll just keep going. Well, in the meantime, while I grab that job ID, because what we can see here is the number of files keeps coming in. So if we look at the one that it errored on, man, this thing works so great, except when people came in. So this is, the file names are the partition and then the offset. So we're at 1,293. So I'm guessing the one that it had trouble on was this one. If we look at this text file, this is just the description from one of those pages. So you can see these people wanted Python, Perl, Bash, Hadoop, Java, Linux, all of this. So it doesn't look like it was this one that it struggled on, because it had Sportsman Warehouse in it. Is it this guy, the 2003? There it is. So let's just delete this guy since it's causing my pipeline trouble. And as you can see, more and more jobs keep rolling in. And we'll keep running it. Just spun through a bunch of them. So now to see the final step here, let's go back to this and look at this redash dashboard, data engineering demo. So basically, we're just going to count the Python versus Java. So if I refresh these, we can see that, so it's definitive. Python is the better language. I'm just kidding. It's not better. It's funny, when I showed this to some of my coworkers, they said that that I should add like Go and Julia and a bunch of other programming languages, which I probably will. PR is welcome to this guy. So yeah, so as it comes in, we can refresh this and we can see that Python count's coming up. So it'll just keep pulling in new data here. So just to recap on this, we're scraping Indeed. Yeah, Jason, it's failing on the unescaped apostrophe. You're right. And the so we're pulling in the URLs. We're listening on this Kafka topic. We are scraping the description page, saving them as flat files, and then we're loading some of the data from the flat files into a warehouse Postgres database, and then we can see that data updated in a dashboard, right? So where does this fall short? What things could improve? First off, tests. I didn't include any tests here. There are quite a few people that would probably, I don't know, defriend me somewhere if they knew I didn't have a single test. Probably would have caught that unescaped apostrophe had I done that. And then other things, obviously logging and alerting are pivotal to any good data infrastructure. We use CloudWatch and the Elk Stack. Datadog is a great logging and alerting company. And then obviously orchestration. So you can see that I ran each of these as just a process. And this is still chugging along on each of those, in each of these. But this could easily be an Airflow DAG or a prefect DAG. There's we could use Luigi. There's a lot of good orchestration frameworks that we could actually just orchestrate each of these steps or make sure they're running. So that's another piece that could be improved on. And yeah, so if you want to get your hands dirty with this, you can look at it. It's just open source. I'll make sure to get a license up here. Probably just use an MIT license. But yeah, if you wanted to see, here's the Kafka cluster running locally. We can see these topics have come in on. We can look at the overview and see how many bytes per second on this cluster we're doing. If we look at the topics, here's the Indeed data job URLs that we published. You can see that, and you can see the messages. So yeah. If we go back to the demo, that's actually all I had. Thank you guys. I really enjoyed getting this together. And if you have any questions that you would like answered about data engineering, or any question, feel free to ask.
Thank you, Casey. We're currently clean on both the Slack channel and in Slido. So it looks like we're good there. Is there a place that you would like them to reach out to you if they do have questions later, or if someone's watching the recording and has a question?
Yeah. So one great place is way at the beginning. It's just mouse11@gmail.com. Go ahead, send me an email. Really open, love to hear from people. So yeah, as we pass the time,
looks like we have one question out on Slido if you're looking for.
Yeah, what's the best pathway for running a Kafka cluster locally? Good question. So it was actually really simple to get this one up. I can actually run through that right now. So this is CP all-in-one, this guy right here. If we go to Kafka, Confluent, oh no, you can see some of my problems that I had. Quick start. So if you just go to confluent.io's, here's an Apache Kafka quick start. And this is what I did right here. So there's a Docker, quick start Docker platform. So then this one, basically what you do is you just clone down this repo, which I did, and then cd into this directory within it, and then just do a Docker compose up. And so if we actually look in here and we go to the external CP all-in-one, CP all-in-one, and then we do Docker compose PS, we can actually see all of the services that it spun up. So it spun up a broker, a connect, a control center, a KSQL data gen. So you can run KSQL against this cluster. And it has a REST proxy, a schema registry, and Zookeeper. So yeah, in a similar fashion, I downloaded Redash, and they also have a Docker compose file that they spin up their needed pieces, and that's running locally as well. That's actually running right here on that Redash. So yeah, that's how I got a Kafka cluster locally. I did think about moving to a managed streams in AWS and trying it there. Decided to do the local route because I thought it would be more approachable in terms of like if someone actually wanted to try this. So yeah.
Awesome. I think we've burned through the questions. That was an awesome presentation, Casey. We really appreciate your dedication, your support of the community, so putting this together today and participating in the conference. This was awesome. Appreciate your help and look forward to hearing from you again in the future.
Thanks.